Alright, in this video, I'll be explaining dilution. For this lecture, we actually have the following lesson objectives. Number 1, explain the process of dilution. Number 2, describe how dilution is done in a chemistry laboratory. And then number 3, I'll be showing problem solving involving concentration and volume using the dilution formula. Let us start. Dilution is the process of preparing a less concentrated solution from a more concentrated solution. Take note, dilution is the process of preparing a less concentrated solution from a more concentrated solution. Ibig sabihin po, ginagawa ang dilution para gumawa ng mas mababang concentration mula sa mas mataas na concentration. Gagawa ng mas mababang concentration mula sa mas mataas na concentration na solution. Dilution is the process of preparing a less concentrated solution from a more concentrated solution. The concentration of a solution is reduced by adding a specific amount of solvent such as water to the solution. Para po mapababa ang concentration ng isang solution, ang ginagawa lamang po ay pagdaragdag o mag-add ng solvent. Ang pinaka magandang example po o halimbawa sa mga ina-add na solvent ay water. Again, to reduce the concentration or to enact dilution, we simply add a specific amount of solvent, and that example or a best example of a solvent is water. So that is dilution in terms of definition and how it is simply done. Dilution is simply preparing a less concentrated solution from a more concentrated solution by simply adding a specific amount of solvent, and one of the examples are water. Now let us be familiar with some of the keywords. So that is, or one of those words would be stock solution. A stock solution is a concentrated solution that will be diluted to some lower concentration for actual use. Meaning to say, ang stock solution po ay mayroong certain amount of concentration at ito po yung stock solution na tinatawag na dapat pababain natin ang kanyang concentration. Again, as defined, a stock solution is a concentrated solution that will be diluted to a much lower concentration. Stock solution po yung parang starting point. Siya po yung gagamitin natin as basis na idadilute. So sa stock solution po ang ating idadilute by simply, as indicated by the illustration, we're going to add water. So stock solution, it has a certain concentration, and then add water, it is now diluted. Stock solution is a concentrated solution that will be diluted to some lower concentration. So stock solution is your starting point. Now, dilution is commonly being done by means of a volumetric flask. A volumetric flask is commonly used in diluting concentrated solutions such as acids. Concentration, or rather concentrated acids and other reagents, are usually diluted first before it is used in an experiment. So in real life application, we cannot use concentrated acids because concentrated acids are very corrosive, especially to our skin, especially to our human hands. So if we would spill even the littlest amount of concentrated acids on our hands during laboratory experiments, it would be harmful and dangerous. That is why when you see people, or maybe you have experienced cleaning your comfort room, di ba, gumagamit po tayo ng muriatic acid minsan sa paglilinis ng mga CR. So hindi naman po concentrated o purong muriatic acid ang ginagamit panglinis. Ang ginagawa po ay lalagyan pa po siya o hahaluan pa po siya ng solvent o kaya solvent tulad ng tubig para ma-dilute. Kasi kung sobrang concentrated ng asido na ito, sobrang harmful kapag ginamit po natin ito sa paglilinis kung puro. Kaya ang ginagawa po, dinadilute po ang ating mga muriatic acid kapag ginagamit panglinis. Kasi nga, kung sobrang concentrated, it would be harmful. Okay? So according to the second point, again, concentrated acids and other reagents are usually diluted first before it is used in an experiment. Even in real-life application, it is being done. A best example would be using muriatic acid in cleaning certain areas of our house, like the comfort rooms. Okay? Now, in an experiment or in a laboratory setup, a simple dilution is being done as follows. So you have here two particular volumetric flasks. So this particular volumetric flask contains the stock solution, meaning to say the solution that needs to be diluted. So using a volumetric pipette, will be gathering a certain amount up until the mark. So say for example, the volumetric pipette is blank or it doesn't have any components or composition. So we'll gather a certain amount of stock solution up until this mark. Okay. Then after which, containing the certain amount or measured concentration of a solution, it will be transferred to the other container. Okay. So the measured volume of stock solution is transferred to a second volumetric flask. After which, using a certain bottle here containing a solvent, say for example water, will be transferring or will be pouring solvent or water to the second container up until the mark. Ulitin po natin. Sorry about that. So starting with this, meron po tayong dalawang volumetric flask, itong nasa kaliwa at kanan. Itong nasa kaliwa ay mayroon pong nilalaman na stock solution. Gamit ang volumetric pipette, kukuha ng stock solution of known concentration up until this particular mark. Then after, we'll be transferring that amount of solution to the second flask. After which, using this particular bottle, okay, so say for example, this is a wash bottle containing water as a solvent, we need to pour solvent or water to the second flask up until the mark. And this entails dilution process. Now, the dilution formula. In carrying out a dilution process, it is useful to remember that adding more solvent to a given amount of concentrated solution changes the concentration without changing the number of moles of solute in the solution. Let me repeat. In carrying out a dilution process, it is useful to remember that adding more solvent to a given amount of concentrated solution changes the concentration without changing the number of moles of solute present in the solution. Ibig sabihin po, kapag ginagawa ang dilution, naglalagay tayo o nagdaragdag tayo ng solvent. Every time na nagdadagdag po tayo ng solvent, nagiging diluted o bumababa o nag-iiba ang concentration. Habang nag-iiba or changes sa concentration, hindi nag-iiba ang bilang ng mole. Ulitin ko po. Sa dilution process, napakasimple lang, magdaragdag lang tayo ng solvent para mapababa ang konsentrasyon o maging diluted ang isang solution. Habang naiiba o nag-change ang concentration, hindi po naiiba ang bilang ng moles of solute sa isang solution. Therefore, we have the following conclusion. Moles of solute before dilution is simply equal to the moles of solute after dilution. Dahil kung pagkatapos mangyari ang dilution process, hindi nababago ang bilang ng solute, we would conclude na ang bilang ng solute bago at matapos ang dilution ay magiging parehas pa rin ang bilang. Moles of solute before dilution is still equal with the moles of solute after dilution. Now, this is what you call the molarity or the concentration formula. denoted by N moles of solute all over V liters of solution. Then the number of moles of solute is given by N is equal to V. Now say for example, M is equal to N over V. So we need to derive the formula for the moles of solute. So derive M is equal to N over V. We got N is equal to LV. Now since the number of moles of the original solution remains the same, dahil moles of solute before is equal to moles of solute after dilution, equal sila before and after yung bilang, we can conclude that M1V1 is equal to M2V2. Thus, this is your dilution formula. Initial concentration multiplied by initial volume is equal to final concentration times final volume. Again, numbers of moles of solute before dilution and after solution are the same, or after dilution are the same. The formula for molarity or concentration is N over V, where N is moles of solute and V is liters of solution. Derive the formula for letter N. So N is equal to MV. Now, since number of moles are equal before and after dilution, we have M1V1 is equal to M2V2. Let me give sample problems. Sample problem number 1. A particular analytical chemistry procedure requires 0.0100 molar potassium chromate solution. What volume of 0.250 molar of potassium chromate must be diluted with water to prepare 0.2500 liters of 0.0100 molar potassium chromate solution? Okay. So let me write the given. The given are the following. So initial molarity, or this will be the initial concentration, 0.250 molar. The final concentration according to the problem is 0.0100 molar. And then the final volume would be 0.2500 liters. The requirement according to the problem is what volume of 0.250 molar of potassium chromate. And then we have the equation M1V1 is equal to M2V2. Okay, so with that said, let me write the solution here. So we have here M1V1 is equal to M2V2. Now, since the requirement is initial volume, I need to derive an equation for initial volume. So that is simple, divide both sides by M sub 1 so that we can isolate V sub 1. It's a simple cancellation. Now at this point, I can simply substitute all given quantities because my concentrations, they have the same unit, which is molar. M, the meaning of M is molar. And then we have here L being liters, that is volume, so appropriate. So 0.0100 molar multiplied by 0.2500 liters all over 0.250 molar. Okay, so the unit molar will be cancelled, and then the remaining unit will be liters. I have actually the same solution with that of the PowerPoint. And input this in the calculator, we have the following answer. 0.0100 liters. Meaning to say, 0.0100 liters of 0.250 molar potassium chromate solution must be diluted with enough water to prepare a 0.2500 liters of 0.0100 molar potassium chromate. Okay, so it's very simple. Let me show another example. Okay, so for another example, let me read the problem. A 15.00 milliliter sample of 0.450 molar potassium dichromate solution is diluted to 100.00 milliliter. What is the concentration of the new solution? Okay, so let me write the given. So V sub 1, that would be 15.00 milliliter. Initial concentration 0.450 molar. And then final volume, according to the problem, 100.00 milliliter. So my volumes have the same unit, and then we have appropriate unit for concentration. And then the requirement is concentration, M sub 2. Equation would be M1V1 is equal to M2V2. Okay, I actually have here the same given with that of the problem, same requirement and equation. Okay, so let me input this. So since the required is M sub 2, divide both sides by final volume to isolate M sub 2. Again, since M sub 2 is the required, using the following equation, the dilution formula, I need to isolate M sub 2. How? By dividing both sides by V sub 2. I have an equation for M sub 2, which is the required. So since the following given are appropriate, so 0.450 molar multiplied by 15.00 milliliters all over 100.00 milliliter. So milliliter will be cancelled. The remaining unit will be molar, which is an appropriate unit for molarity, or rather concentration. Okay. So I have here the same solution with that of the PowerPoint, the same substitution, and then input this in or rather, sorry about that, input this in the calculator, we shall have 0.0675 molar. Okay, again, I have here the same derived equation, the same substitution, and then when we input this in the calculator, we shall have 0.0675 molar concentration. The concentration of the resulting solution will be 0.0675 molar. So let us analyze the given. Since we're talking about dilution, meaning to say, from more concentrated solution, it shall become less concentrated. Again, dilution. From more concentrated, it will become less. Okay, ADP. Dilution is becoming more concentrated, it will become less concentrated by adding solvent. Okay, by adding solvent. Now, look at M sub 1. M sub 1, 0.450. Dilution becomes 0.0675. From more, 0.450, it becomes less, 0.0675. Because your initial volume, 15. And then your final volume, it becomes 100. There was an addition from 15, it becomes 100. So from more concentrated 0.450, it becomes less concentrated 0.0675. Thus, following the concept of dilution. Okay? Alright. Let's have another example. How would you prepare 60.0 milliliter of 0.200 molar nitric acid from a stock solution of 4.00 molar nitric acid? So let me write the given. So how would you prepare? Okay, so my given would be my initial concentration would be 4.00 molar nitric acid. My final concentration would be 0.200 molar, and then my final volume would be 60.0 milliliter. Bakit ganito? Bakit biglang naging ganito yung arrangement? Akala namin kung ano yung unang nabanggit, sila lagi yung M1 tsaka V1. Not necessarily. Kailangan po natin ng comprehension. Okay, how would you prepare? Ang tanong, paano mo gagawin? Paano ka makakagawa ng 60 ml na 0.200 galing sa stock solution na 4.00? Ayan na yung clue, stock solution of 4 molar. Alalahanin, pag sinabing stock solution, yan laging starting point mo. So stock solution, starting point, M1, 4.00. Tsaka sinabi no, how would you prepare? Paano mo gagawin? So dapat, ito yung maging final, ito yung magiging resulta. So M2 would be 0.200, volume 2 would be 60.0. Plus, alalahanin, ito po ay dilution. Tingnan mo, dilution from more becomes less concentrated. 4 is higher than 0.200. More becomes less concentrated, dilution. Okay? Alright. I actually have here a typographical error. So this is not the case. Okay, so this is the correct arrangement, or rather this is the correct assignment of the M sub 1 and M sub 2. This is a typographical error. Sorry about that. Okay. All right, so let's proceed on this particular case. Okay, so let us have here the requirement would be M sub 2, or sorry about that, V sub 1. Okay, so our equation M1 V1 is equal to M2 V2. Okay, so since our requirement would be V1, so divide both sides by M1. So that remains, what remains here is V sub 1. M2 V2 all over M sub 1. Okay, so we now have an equation for V sub 1. So input the following given. So we have here appropriate units for the following. So M sub 2 would be 0.200 molar multiplied by 60.0 milliliter all over 4.00 molar. So molarity will be cancelled. What remains is the unit milliliter. So let me have a calculator with me. So 0.200 times 60.0, 4.00. So we have this particular answer. So we have here 0.200 times 60.0 all over 4.00. We have 3. So 3 significant figure, that would be 3.00 milliliter. Okay. And then going back to the question, how would you prepare? Kasi paano daw tayo makakapag-prepare? So to answer this one, if our initial is 3.0 milliliter, to prepare 60.0 milliliter of 0.200 molar, to prepare again, kung ang sagot po natin, kung ang initial po ay 3.00 milliliter, at ang tanong ay, how would you prepare? Paano ka daw makakagawa ng 60 ml na 0.200 galing sa 4.00 molar nitric acid? Ang maging sagot ay, from 3.00 milliliter, add 57.00 milliliter to 3.00 milliliter of 4.00 molar nitric acid to prepare 60.0 milliliter 0.200 molar. Okay, so let me repeat. Ang tanong, How do you prepare? Paano ka daw makakagawa ng 60 ml of 0.200 molar? Ngayon, na-solve natin na ang V sub 1 ay 3.00. So, ang initial natin ay 3.00. Okay. So, ngayon, paano mo daw gagawing 60 ml of 0.200? So, to answer that, add 57.00 ml to 3.00 ml of 4.00 molar. So, napakasimple. Since 3 plus 57, that is 60. And this 60 represents this particular 60 ml of 0.200. That is why, to prepare 60 ml of 0.200 molar, add 57 milliliters to 3.00 milliliter of 4.00 molar nitric acid to prepare 60.0 milliliter of 0.200 molar. Okay. And just to check if this particular solution follows your dilution process. Okay, so again, dilution is from more concentrated to less concentrated by adding solvent. So our initial is 3.00. And our initial concentration is 4. From being more concentrated, it becomes 0.200, which is less. Plus the fact that we added solvent from being 3 milliliter, we added 57 milliliter to make it 60. Thus, it follows the dilution process. Okay? Let me just reshare my screen. Okay. All right. So let us check if the following lesson objectives were attained. Number 1, explain the process of dilution. Yes, it was explained a while ago on the former part of the PowerPoint or the former part of the presentation. Second is to describe how dilution is done in a chemistry laboratory. So it was also explained and described as well by means of an illustration. And then thirdly, I actually showed you problem solving involving concentration and volume using the dilution formula. Right? Thank you. I hope you learned a thing or two about dilution.